Okay, I think we'll start. First of all, thanks for attending. I know it's late in the afternoon and you've seen a lot of sessions in the past couple of days. This one is about PowerCLI, and it won't mention Azure. That's the only time that you will hear that word in this session here today. For the rest, it will all go about VMware PowerCLI. What I would like to show you, and I intentionally kept it light because I know the time of the day is not up for lots of lines of code. What I want to show you is how I adapted or how I customized the PowerCLI core version to work under a PowerShell core. We'll see later on some of those steps that I did. First of all, a few things if you later want to contact me or want to know who is in fact talking to you from this stage. I'm into automation. I've been doing a bit of PowerCLI and PowerShell in the past. I had co-authored a book. There's some handles there to my blog, my Twitter handle, and you can find me on the VMware community as Luc D. So if you want to reach out later on, feel free to use any of those contact mediums. What are we talking about? First of all, we're going to explore what PowerCLI, the core version, offers you at this point in time. I intentionally said point in time because the thing is changing so rapidly that probably by tomorrow my session will be outdated and the people from VMware will have a solution for some of the things I will mention here. Some people might see that there's some problems when you start using PowerCLI running on PowerShell core, but in fact there aren't. There are a few that you can't avoid at this point, but a few of them, the majority of those you can bypass, but one way or the other, and that's some of the things I'm going to show you. Now, the fact that you're running on core also gives you new opportunities. I'll show you one example that I implemented based on running PowerCLI on PowerShell core. And then we'll make a conclusion, some of the things that you could take away from this session. And there will be a Q&A, but feel free to interrupt me to ask questions anywhere in the session. There are some people from VMware, the PowerCLI team in the room, so if there's something I don't know, they probably know the answer, so use that opportunity. Okay, a bit of history. At the moment, the product is called VMware PowerCLI. The VMware is there since 2-3 years. I don't remember exactly. It used to be vSphere PowerCLI. Then it became VMware PowerCLI because it covers a lot more products than vSphere itself. Horizon is in there, NSX is in there, and VRO, and so on and so on. There's a lot of community contributions as well, even complete modules. The original product is 11 years more than 11 years by now, old. So that's what I just said. What is important when Microsoft, Jeffrey Snover announced PowerShell core, on that same stage was the then PM of PowerCLI demonstrating how PowerCLI ran on that PowerShell core. So they were in the very early days already adapting to that new format or form of PowerShell, especially since you can now run PowerShell and consequently also VMware PowerCLI on several Linux distributions and on Mac OS X OSs. Now what you can do and how they deliver it side by side for the majority of the modules since 6.5 release 1, if I'm not mistaken. That means that in the same installation you have both modules. So if you would be running PowerShell 5.1, for example, and PowerShell 6 side by side on your Windows platform, this is only possible on Windows. On your Windows platform, you could still use the same modules. In reality, we'll see later on that it's slightly different depending on what version you are using. Their release cycle is incremental. So they keep adding new features, new modules. Last year was tremendous, I think 6. How many did you have last year, Jake? 6 releases. So I'm not sure there are a lot of other products that come at this rate, and especially the guys from Sofia who write the stuff, in fact, did a tremendous job there. Now, one of the things that I often see coming back, and I know this is not directly related to core, is that people, since they have that rather high release rate, that people keep accumulating different versions of the modules on their platforms. In itself, that is not a big deal, since PowerShell will be smart enough to take the last version that is available on there, the last version of the module. But sometimes it could be interesting to clean up. Now, how do you see that this is available and for PowerShell, the Windows version 5.1 and the core version? You see those two subfolders under there. So they have in their implementations the files necessary for running it on Net 4.5 or Net Core 2 at the moment. So that's those two branches that you have. What I'm showing here is how you could clean up this environment. So as you can see, we have there in the example 3 versions of the same module. Ultimately, you want to clean up the older ones, 11.1, 11.2, and only keep 11.2. I repeat, it's not necessary, but for cleanliness, that is sometimes handy to do. This is a small piece of code, I think, that is available on multiple platforms nowadays, how you can do that. The only thing you have to watch out for, if you do feed your modules directly into uninstall module, there is a quirk in there. It only seems to take the name and not the release, the version number. So that means as a consequence that it will throw away your last version as well. That's why I used in here a for each loop, where we then have access to the complete info that we get from get module or find module, and we use and the name and the version for the uninstall module. So if you want to clean up, take care. If you just pipe it into an uninstall module, you risk removing the modules that you don't want to remove. By the way, for those of you who don't know, I use splatting here. First of all, then it fits on one page. Otherwise, we would have very long lines. If you're not used to that, that is something that you definitely should be looking at. You can group all your parameters in a hash table and then with the @ sign pass that hash table to the call to the commandlet. Also quite important here, and that is something that you should in fact do quite often. Oh, sorry, I'm too far. This what if switch that I have on the uninstall module. If you're testing whatever script, and there is some stuff that can be removed or will remove something, run it first with this what if. Once you're sure, it will show you what it is going to do, but it will not do it in fact. Once you're sure, throw away the what if, and then you have an actual action that it throws away the modules. Now also watch out. Some of these will require you to have admin access. If your modules are installed with the scope all users, it will go in other folders than when it's current user. Then you will have to run the script from a prompt that has admin access. Also, and there have been several sessions on there in this conference, Visual Studio Code should by now be your editor of choice. One nice feature that I particularly enjoy is, since I'm working on a Windows platform, there is this option to run both versions side by side, even in your editor. So if I'm developing code or writing a script, I write a script in the editor window, and then underneath, thanks to the shell launcher, which is an extension, which you should absolutely have a look at, you can open both versions at the same time. That's what you see here. I'm now running 5.1 and 6.2 next to each other, and depending how I launch my script, it will run in one version or the other. So ideal if you want to cross-develop for both versions in this editor, that is possible. Okay, this is again the two versions that I'm using in the same instance of the Visual Studio Code editor. Let's have a look at the modules, what is in there and what is supported in 6 and what isn't supported in 6. When I made those slides, and it's still the latest version, that is 11.2, there probably, with their rate, be a new one soon, but that's the one that everything that you will see from here on is based upon. So 11.2 if you want to redo or replace some of those things later on. One thing you should be aware of, I said the modules come side by side, but they're not always installed in the same location. So if you install it on a 6 platform or on a 5.1 platform, the ultimate directories where they go, they are different. And this might have impact on your scripts, your testing. These, and again, I use this 2 version windows at the bottom. I'll highlight the differences. If you install it in 5.1, that's on the right side, you see that your modules will appear in those classical folders. But if you install it in 6, watch out, these are different folders. So depending where you do the install module, you will end up in different locations. This is just an overview, a small script. I'm not going to bore you with the script, but I accessed all the modules, and what I did is I tried to determine which ones had a version for core available. As you can see, most of them have, it's the right side column. All the ones with true, they run on core without a problem. The others, they are or in the making or are planned. If you want more details, that's something you should ask the VMware people when and how, although they won't tell you anything about the roadmap. Another interesting feature is if you want to have the date when a module was actually produced, there is in these modules nowadays a CAT file, a catalog file, and you can extract from that catalog file. You know, if in Windows Explorer, File Explorer, if you open a file, there's a tab with details which gives you the create and the last change date. You can extract that in a PowerShell script, and that's the date that you see over here. Otherwise, you would have the date when you installed it on your system. This way you can find the actual date when it was packaged in Sophia, I suppose. So you know when a specific version was created. The main module, the core module, there's a number of commandlets in there that don't run. So if you start those in PowerShell core, they will give you a nice message. This commandlet is not supported in core. This is the list. Again, you can extract that from the module itself by a small script. So there's a few in there, and I know that it's not complete. There are some that work under core, but not completely. But the primary ones here are everything that is involving the Credential Store. We'll go into those later on. There's this one that opens a console window with VMRC to a VM. I don't know why it's not supported, because for me, if I create a URL myself, it works with VMRC if I install it on Linux. So if somebody cares to explain why that is marked as not supported, I don't know. And then there is the hardware commandlet, which is most probably, is my assumption, that it's due to the WMI part that you are using, or the IPMI part, to extract that data from the hardware on which your hypervisor is running. So these are a few that you won't be able to run as is on a core platform. I deliberately said as is, because what you want, in fact, and I know it from the place where I work, we have a huge amount of legacy scripts that are already there, and we don't want to go around changing all those. So what we were doing, we were looking for solutions that didn't involve editing our original script, something that we could do outside our script in such a way that the commandlets could stay, the lines could stay in those scripts as they are and were. So that was our target. Okay, the modules that are not ported yet, there is not really a solution unless you write yourself a new model. But I think that is a waste of time, seeing that they are planning a lot of these modules to be ported soon or a bit later. I don't know why. When. There is also the Windows Compatibility module. Who heard of that module? It was announced end of the year, last year, okay? The promises with that module were quite high, and I had high expectations, but when I tried it with PowerCLI modules, I'm afraid it doesn't really do what it's supposed to do. So That one was not a solution. That was the first one we looked at, but I'm afraid we at least couldn't get it to work. If somebody else can get it to work with the VMware PowerCLI modules, I'll be more than happy to know how they did it and what you have to do specifically. For functions that are not supported in the core module, the 6 or 7 that we saw earlier, there you could write your own functions or you could adapt the ones that are there. And that's the thing that that's what I will show you in the coming slides, how I did that. What is important here is to understand command precedence. So you can have multiple formats to execute something in PowerShell. You have functions, you have commandlets, and so on, but there's a precedence that the system uses. And you probably all read this because this is an about article in your PowerShell installation about precedence. This is something that is important. So if you have a function with the same name as a commandlet, your function will be taken, not a commandlet. Same goes, the lowest level is command, but what it means here, that is a DOS command, or on core, it would be a Linux command, PS, ls, whatever you want to run. That is the lowest priority for the PowerShell engine. What is amazing, and I have to admit, I didn't know that before I started rereading the about precedence article, aliases even have a higher priority than functions, which I think is a very dangerous thing because you could easily alias your way into whatever and intercept a lot of the functions or commandlets that are there. But there's probably a reason, I don't really know, but aliases have a very high precedence, or the highest precedence in command execution. So the priority goes left to right here. So like I repeated, like I already said, one of the solutions is you can rewrite the function instead, your own function instead of the commandlet. So if we tackle the Getvm host hardware commandlet there, the reason, as I suspected, it's probably WMI, and I know from past experience that that thing is very hardware vendor and type and model dependent if it actually returns all the data that you want it to return. How do you get those functions above? There's several ways. One of the ways that you can do is you can put it in the profile. So if you define those functions that we are going to use in your profiles, they will be known for the session when your session is started. Or you can dot source them before your script. That means you would have to write a wrapper where you first dot source your new functions and then your original script. That's another way of doing it. There's multiple ways of doing that. That's entirely up to you. So let's have a look at this Getvm host hardware commandlet. The info that is returned by that commandlet is mostly there. So if you look at vSphere object representing a host system, an ESX inode, most of that information is there. The one that is not directly in there, you can obtain through ESX CLI command, which you can do in PowerShell with get ESX CLI. And make sure you use the V2 option. That's the one with the most features and the easiest in use, as you will discover. Ideally, I would like to have this function create the same object as what the commandlet returns, but unfortunately at the current implementation that doesn't really work. You can't do a new that is not read-only, but I think they are aware of that. I, in fact, launched an idea to make it, because it also plays when you're doing pester testing, for example. If you want to mock an object, you need to be able to create an object that you can change, not a read-only object, but that's on the side. Now, for our purpose, in this case, for the VM host hardware, that is not really a problem as long as you only want to see the properties in the object that is returned. If you have tests in your script that are going to test on type of the object, that will not work. That is something I can't do at the moment. In summary, this is a small summary of the function I wrote to do the same or return the same data that the Getvm host hardware commandlet returns. As you can see, most of that is available through the extension data or through the get ESX CLI commandlet. So all that information is nearly there, except a few, but then they are marked in yellow here. But in fact, if you use that on most of the hardware that I used it, they were blank or empty or showed an empty object as well. Again, I suspect that this is very vendor type and model dependent what actually is returned in those fields. So Getvm, most hardware in that way can easily be replaced. We make a function, it returns the data as you used to have it from the commandlet. Now for the other one, and the important ones, is the Credential Store. There's a lot of people that have been using it, which was a good concept, where you store the host name and your credentials in an external file, and it was encrypted. Now, unfortunately, it was encrypted by a Windows-only method, the DP API, which of course is not available on PowerShell Core, since we are using .NET Core in there. But there have been some presentations, and this is old stuff. In 2009, the link is in the presentation. Jeffrey Snover wrote a post on the proxy commands. And in that same year at VMworld, yours truly here had a presentation on the same subject. What we did at that point is we expanded the getStat type commandlet to not only return the metrics, but also the instances that were available. So the concept is already quite old, but we can now use this to replace those commandlets that normally give you this pop-up. It's not supported in Core. There's several ways you can create this proxy command. There's first of all the raw method. That's the first paragraph that you see in there. There you really go into the object and create it. There is a module available with a new proxy command in there, which makes this a one-liner. What comes out of this is a kind of a script, which represents the command. So we'll have a look at what comes out here. So you have a PS1 file that comes out, and in that PS1 you will find the function declaration. You will find parameters, and that is the interesting part. You will have the parameters with the exact attributes as they are used in the commandlet. You will have a begin, process, and end block. Now the good thing here is that code is normal PowerShell code, so you can intervene. For example, in the begin block there is this PS bound parameters, which is I simplify, which is an array containing all the parameters that you passed to the commandlet. So you can go in there, add, remove, change parameters. Second thing is there is this call command. So once they passed that PS bound parameters adaptation, they will call the original command. Now, you don't have to do that. If you want to replace the commandlet completely with your code, you just don't call it. If you call it, it starts up a pipeline, and then you have the classical 3 steps in a pipeline: the begin, the process, and the end. Again, that's something that you don't necessarily have to do, but this is a good template to base those functions upon that you can use to replace commandlets. So, to summarize, the PS bounds parameters, we can change, add, or remove parameters. And then the call command, we can call it or we don't call it, and we replace it completely with our own code. Now, the first thing I discovered is that you should never use parameters that correspond with the names of predefined variables. And if you know, in the Credential Store commandlets, they use a parameter which is called host. This is probably all working very well because they code this, but if you use a proxy command and you now pass a parameter host, the system will come with a nice error. You can't change a constant or a read-only variable host. Now, luckily, PowerShell has possibilities to change that, and with a few tricks you can buy. So that is the problem. We have a parameter which is called host, which will make sure that our function does not work like that. But we can easily replace that. Each parameter, as you know or don't know, can have an alias name. So you can have multiple names to a parameter. In this case, I just moved host to the alias because apparently the aliases he doesn't check. He only checks the actual name, and that one I gave a new name, host entry in this case, whatever you want to call it. But you just keep the host in the alias, so you can still call it. Your old scripts who call it with the host parameter, that will work. It's an alias. But internally, it will be represented by the parameter or the variable host entry in this case. So I didn't submit this yet, but I think this will become an idea in the coming days, probably, that you consider changing that. This is recapping what the Credential Store, in fact, does. It uses the DP API, which is a Windows collection of APIs. It stores the file, stores the credentials in an external file, which you can only read when it's the same user on the same computer. That's a limitation of the DP API methods. How can we replace that? So we now have the skeleton in which we can inject our code. How can we? There are multiple possibilities. If you want it quick and dirty, you just hard code your values in there. Most security officers will now have a small heart attack, but that is one solution. You can do it that way. Another option is to store it on an external medium and do some sort of encryption depending on the platform where you're running it. And the third solution, which is the ideal solution, is to use a vault. And we'll now run through these three possible solutions. And in fact, the examples I'll show you are for the new VI Credential Store item, but they are equally valid for the other two that are available there. So the get and the remove as well. The remove will probably not do a lot with the hard-coded values, but with the others it will work as well. So if you have it hard-coded, new and remove don't really make sense because you hard-coded it. It's quite simple. You take a hash table in whatever, or you can take whatever format, multiple variables. The point is you store the credentials, so the host name, the name of the user, and the password in your function, and then you can call your function and it will return, in this case, those values, just like the get VI Credential Store item does. So that's the easiest but the most insecure solution, but it works. Oh, my highlights come a bit soon here. The other one is with an external file, but now that's building up the tension, now you know where the surprise will be. The external storage, and I did that on a Linux box, so we have access to a number of tools that are readily available on most Linux distributions. I use base64, but you could use PGP, OpenSSL, whatever you want. The fact is that you're just encrypting a clear text string into a string that is somewhat more secure. This again is the code. Basically, it's not very high level. The only thing what we do here is the password that is passed, it's the lower yellow box. We just pipe it, yes, you can pipe on Linux as well, to the base64 command, which encrypts it. And then it is stored in an XML file on that platform. So it's the same concept, what they did with the DP API, but now adapted for a Linux environment. And like I said, base64 is the simplest form, but you can go for PGP or OpenSSL, whatever you want to use there. For example, I'm not very familiar with Mac OS. If they have another way of encrypting, you could easily replace it by one of those. And then again, when you want to extract it, the get commandlet, in this case, there's one extra parameter to the base64, is the D for decrypt. So that's the way you will get back the same information that we had earlier and that you are used to getting from the get VI Credential Store commandlet, host, user, and password. I know that the original one also has a file parameter or property that it returns, but at this point, you can edit, but at this point I didn't see the value in adding an extra line here to do that file part. But it could be done. Now, this is the interesting one where we go for an external vault. What I did is I had 2 Photon machines, and on there, with Docker Compose, I install 2 solutions. One is the PassBolt solution, which is a vaulting system for teams. And I used MailU because the vaulting solution needs a mail solution as well. So I needed to install mail solution in the platform as well. You could install it on 1 Photon. I did it on 2 Photon machines. The advantage is I can spin this up. My disks, the definitions for the PassBolt make those permanent disks with an external storage. So I can start these machines up as I want. There's no reason to keep them running all the time. The complete definition, I'm not going to go into that in these slides, but if somebody is interested, we can have a look. I'm around. Basically, it's done by a JSON file with all the definitions in there, which I execute inside the guest OS, the Photon guest OS, through invoke VM script plus. So any vault will do, whatever solution you have. The only thing that I found interesting in this solution, okay, this is what I just said on the only thing that I found interesting, and I think should be in every solution, whatever one you pick, is that it should have a REST interface. So in this case, you can address that solution with simple invoke web requests calls from within your function. In this case, the PassBolt has that. Somewhat strange setup, but it works. So what they do is when they store credentials, there is always the resource, and then the password is stored separately. So first, with a simple invoke REST method, I get the resource itself based on a number of parameters. Nothing fancy here. And then the second part is you got an ID, the ID, a number from that first call. With that same ID, you can now call and retrieve the password from that same vault. So again, like you see at the end of this code, we can now return to the caller, the host, the user, and the password. The only difference is this is stored in an external vault where you can explicitly specify who can ask this, from where you can ask that information, which is, in my opinion, the more secure solution. Takes a bit more work, but it works without an issue. Now, one that was not in our list of commandlets that are not ported to OS Core, but Core has an impact on it. If you remember, or if you used to do that, you could call connect VI server with just a server parameter. And then he knew from the store where and how he should connect, in fact. With our proxy commands, we can simulate the same thing. So we can make a proxy command for connect VI server and intercept this and see if there's only a server, we're just going to fetch the user and the password from whatever of those 3 previous solutions we selected and still make the connection. So based on that solution, it is quite simple. Now we're using actually a real proxy command. That means we are adding parameters or changing parameters and then calling the original function. In the previous ones, we couldn't do that because then we would again get the message, this commandlet is not supported on OS Core. There we had to remove the call to the original commandlet. Here we will call the original commandlet. Now, as we saw in the schema earlier on of a proxy command, all the magic happens in the begin block. That's where you do your testing. I'm not sure if you can all read that, but the logic is quite simple again. So we just test if there was a user parameter passed on the call. If not, we will get it from the Credential Store. If there's only one returned, then we will add new parameters or change, replace values on parameters, users and password, and our connect VI server goes through in the same way by only adding a server, but using the database to find what credentials we should be using. So in this way we can, and that came in our scripts quite a lot, connect VI server with only the server parameter, this was really a lifesaver for those scripts. So again, in summary, we used the old one, the commandlet that we converted previously, and then we passed the two parameters that we retrieved from that commandlet. This is the part where you actually call the original connect VI server commandlet. So this is not really important for this solution. It's just to show you that you know how such a proxy commandlet. This is the part where we do the actual call. So you can see back, and you can see in this list that he gets the metadata, and then in the end, on this script CMD, he wraps the command. He uses the wrapped commandlet and the parameters that we just adapted, and then he starts the pipeline, if there is a pipeline on that commandlet. So you can do that with all commandlets, in fact, but in this case, it helped us solve the issue that we didn't want to touch our original legacy scripts. Now that I had a solution working with the Credential Store, and I used the one with the teaming vault, I came up with another solution. One of the problems that has been there for quite some time is you can define alarms on your vCenter, but in a vCSA you have the problem that it's a black box, in fact. You shouldn't really be touching it. So running a script when it was still a Windows-based vCenter was quite easy. It was locally on that Windows server that you had to store the script, and it would be run or ran from there. You shouldn't be doing, and you probably can't do that on your vCSAs. And I think that in the next release, the Windows-based one will be gone completely, if I'm not mistaken. I think so, yeah, okay. So it's only vCSA. William, who else wrote a couple of articles quite some time ago, 3-4 years ago, on how to do that. One involved using the Python interpreter that was there on a vCSA, but again, you're touching your internals of your vCSA, something you shouldn't do. And then there's the more general one, how to run a script from a vCenter alarm. So I wanted to do the same thing, but without actually touching my vCSA. And since we are now on core, I could do it quite easily. Again, spin up a couple of machines, use Docker containers if needed, or run it natively on the OS of that machine, Photon, Ubuntu, whatever. That was new possibilities. You can do this on a Windows box, but I have no experience with containers on Windows, so that's why I naturally went for a Photon machine in this case. The concept here is quite simple. You define your alarms to send an SNMP trap, and we will use the SNMP trap as the trigger for the scripts that need to run on that machine or from that machine. It's not a new technology. Other solutions use this as well, this concept, but in this case we could use it to run scripts triggered by something that happens on the vCSA or by a user event, which can also trigger a trap. In schematics, it's quite straightforward, as you can see. So from the vCSA, we send an SNMP trap. We have a machine running, which we have defined as the SNMP target. On that machine, we can have, it can be a VM, it can be a container, it can be a physical machine, whatever. It's whatever we define in the SNMP setup on the vCSA. In there is something that will read the data that is contained in the trap that it receives, and based on that data, it will start one or more scripts for a specific entity in your vSphere environment. So the scripts are or located on the same machine, which we can easily do via a repository. We just clone it when the machine starts up. Or we can have a dedicated machine. Thanks to PowerShell remoting, we can start from machine A, scripts on machine B. That should not be a big problem. Recap again, configuring SNMP on Windows in vSphere is something that can easily be done with the ESX CLI commandlet. You even have, as you can see in the last line, a test trap that you can send, and I used that one in the beginning to see if my concept worked. That worked, except there was one problem. .NET has a UDP client, and it's an async client. That means when something arrives at that UDP client, it will trigger an asynchronous event and will start a delegate. But the event threads in a .NET environment, they don't have PowerShell. So you needed to find something to link those events that came in with something that can trigger a PowerShell script. And you couldn't intercept the events with PowerShell because there is no PowerShell there. And after some searching, long searching in fact, I found a very old solution provided by Uysen in 2009 already. What he did is he wrote a small function which does exactly that, and he uses the register object event, which is available in PowerShell since PowerShell version 2. So what you can do is you have some code, which he wrote in C#, then he links that one with the register object event, and that is the way how we can now see if some data arrives on that UDP client, we get a warning in our PowerShell script and we can intercept and read and interpret the data. So what we get in is in fact the SNMP data block. And once we receive one block, we have to rearm it. So it has to go again, the event registration. But I tested it, I fired, what was it, a few thousand in a couple of seconds, and it could handle it quite decently. Depends, of course, on the performance that you can put on that VMware, the interceptor, or where these SNMP traps are sent to. But it can scale, that is clear. And you can have on vSphere multiple targets. As you know, SNMP targets are UDP, so you can in any case never be sure that the thing arrives. So out of security, you could have 2 or more of those receivers, but then you need to have a synchronization mechanism somewhere, which adds another layer of complexity. That code, I'm not going to go in too much detail. Again, if you want to see the complete script, feel free to jump me later on, and I will gladly go through it. But some of the key points, this is how you set up this UDP client. It's quite straightforward. It's a .NET function. Also available in .NET Core, so no problem that it's Windows related. You can run this on whatever version of PowerShell. This is where we actually, this is a code block that we have actually link to that event that is received. So this is what is executed when an SNMP data block or trap comes in. What it does, it just receives it and puts it in a buffer where we can pick it up later on. All quite straightforward, standard net coding, to be honest. This is the block in our original script where we see if there's something in our buffer. Once there is something in our buffer, we put it somewhere else. In this case, I just send it to format hex to show that something came in. But you can, from here, send it to another thread where the logic, what script is started, would be executed. And then the last 2 lines, you rearm your UDP endpoint again, and the loop starts again. So this would run in a continuous loop or on a timer, whatever. I run it on a timer, but you can run it in a continuous loop as well. Now, the SNMP data is raw, and I was of good hopes that there would be, of course, a PowerShell module that would help me interpret the raw data, but unfortunately there isn't as far as I can see. So instead of installing something, a module, there are a few SNMP modules, but they didn't do the actual task that I was looking for. So I decided, since the SNMP traps, when they come in, they are nothing more than ASN abstract syntax notation language. They are quite simple to interpret in a recursive function. So I wrote my own, which you can also have a look at if you want. What you do need, that data is numbers only. You need to read and interpret the MIB information database that is provided by VMware. And there you will see that that specific alarm can be recognized by that specific code. So I use that to interpret the data. So what happens, in fact, I have the raw data coming in. I first extract the ASN1 syntax, and then based on that, combined with the MIB data, I have my actual information, which allows me to start the script locally or remotely. So visually, this is what comes in. This is this format hex that I showed earlier. This is the data. This is your SNMP trap. Translating this to an ASN1, a PDU block, is in fact the same thing that Wireshark does when he interprets such a block. And as you can see, there are multiple entries in there. You see the old state, the new state, you see the object, the entity on which the alarm was triggered. And there's more information. You have the type higher up, the specific trap, number 2 or 3. So based on all that information, you can now, with a small database or whatever, you can trigger corresponding scripts. So this complete flow is something that you can automate. You start up a VM, deploy your solution. The solution is available in a container. You start it up, one more, whatever you want. And you can trigger and schedule scripts in your vCSA without even touching the contents of your vCSA. I was quite happy with that thing. I promise to keep it light, so there's no a lot of code. I'm not even sure how long we have left, to be honest. 3 minutes. Okay, then we just go quick through the takeaways. New opportunities come with PS Core, that was obvious. Problem solving is a lot, and that is a summary, is combining your knowledge and techniques. We saw some of those. And the last one I find equally important. There's a lot of information in the community available. If you just look at this function from Oysen that I found from 2009, that helped me realize that concept that I had there in the beginning. So community is important, even if it's somewhat old. It doesn't lose its importance. Since we are over time, I think if there are questions, I'll be outside and I'll let the next guy prepare his presentation. Thank you.